Hello everyone, this is the first lesson recording for IM2, September 8th, 2020. So what did we do? We actually started off with the warm-up exercises. So if you were not here, please go to desmos.com, student.desmos.com, and type in this class code and get started on the warm-up. We also started on a quiz. So if you were absent for this, you need to contact me as soon as possible to make up this quiz. Otherwise, your quiz grade will be 0. And this quiz grade will replace the quiz 1 grade if it's higher, because this quiz retests you on solving equations as well. There are 8 questions, 12 minutes, and question 5, you need to explain how you need to either show your work or explain in words. Okay. Alright, let's get started. We do not have time for this, unfortunately. And also next week, next Monday, you're going to have Unit 1, Unit 2 tests. That means anything we covered as classwork or homework is a fair game. So you need to make sure you understand everything and go over the homework. There will be a study sheet available next class. And just so that you are aware, unit tests take up 45% of the overall grades. That means that it is much higher than the quiz, which is 25% and 15% for homework. So this is important. This is really going to affect your grade significantly. So make sure you are prepared accordingly, please. Goal for the day, we are going to work on naming angles accurately, because I find that students are still having a hard time naming and or understanding what angles we're talking about. Okay, as well as definitions of angle pairs and positional relationship, and using that to solve problems, and finally the angle relationships in parallel lines. So to start off with, we watched a short video on naming angles explained. It's a 3-minute video. The link is on the resources. Please watch this, because this is going to graphically show you how to name angles. Alright, so now that we've watched that, the notation, naming an angle, we can name this angle as P. Why? Because that's angle P is the vertex. P is the vertex that for this angle. But you can also use the 3 letters to name this angle. Just like the video said, we use the 3 letters, and you need to follow with your eyes. And B, P, A, you need to sort of just go along, say it out loud. B, P, A encloses this angle here, okay? And the letter in the middle is always going to be the vertex of the angle. So that's really important. You can also call it A, P, B. Either will be fine. Okay, using 3 letters is going to be a lot more preferable in general, just because it is less confusing. It's less ambiguous. Okay, angle notation, angle versus angle measure. Angle BPA is the geometric angle object. That's what we are referring to. Okay, it's the object. Measure of this little m of angle BPA is the number that represents the measurement of the angle. Okay, so say if we said this angle was 30 degrees, then measure of angle BPA is 30 degrees, not angle BPA is 30 degrees. This is just a notation issue, so make sure you understand the difference between measure of and then angle BPA. Angle congruence. How do we determine congruence? Congruence just means exactly the same, right? That's the layman term. How do we prove congruence? We can say that 2 things are congruent if when you do a rigid transformation, that's translation, rotation, reflection. When you do any of those, and you can carry one thing over to the other and it matches up exactly. Another way you can prove congruence is if they have the same measurement. Say if this angle and this angle have the same measurement, then we can say they are congruent. So angle A is congruent to angle B, which means that measure of angle A is equal to measure of angle B. Alright, so then this were the warm-up problems. Okay, then let's just quickly go review on the angle measures. That was an acute angle, right angle, obtuse angle, straight angle. Those four words you should really be familiar by now. And now can you visualize these angle measures? Okay, it's really important that they mean something. When you have a 90 degree, when you say here a word 90 degrees, okay, do you have a picture in your mind? When you have a 180 degrees, when you have a 45 degrees, do you have a picture in your mind as to how big they are? I want you to pause the video and just quickly jot down this table and draw an angle that represents 90 degrees, 180 degrees, 45 degrees, and so on, please. And I'm going to show you the answers in 3, 2, 1. Okay. So this is 90 degrees. You should have this right angle in your mind. Every time you see a 90 degrees or right angle, this is 90 degrees, okay? 180 degrees is a straight line. Okay, now what about 45 degrees? 45 is half of 90 degrees, right? So if you can kind of picture half the measurement of 90 degrees will look like this. What about 30? 30 degrees will be about a third of this 90 degrees. So if you can divide this into 3 parts, it will be about there. Okay, so have a picture in your mind. How about 120 degrees? 120 degrees is bigger than 90 degrees. Okay, it's bigger by about 30 degrees. So you can kind of picture it as this angle plus this angle. And that will end up with about approximately there. 240 degrees. It's not quite 270 degrees, which will be all the way around. It's the reflex section angle going from outside. Okay, that's 270, and 240 is less than that, but more than 180. And then 360 degrees is just a full revolution, full circle. Okay, so make sure when you see these numbers, you have a picture in your mind as to how big the angle is, because that's going to be a real clue to you whether you're making mistake or whether you're processing things differently or something does not make sense. Alright, so then we talked about linear relationship. The two angles, if they form a straight line, then they are always going to add to 180 degrees. Okay, also we talked about vertical angles, and that when they are opposite one another, then it is going to be identical. Vertical angles have the same measurement. So measure of angle CEB is 23 degrees, because we know that angle AED is 23 degrees. Alright, so at this point, I am going to ask you to get fresh double page. If you're using a notebook, get fresh double page. If you are using a binder paper, just get a fresh page, and you are going to label it that looks like this. The first page should look like this. The second page should look like this. Okay, the first page, and I'm going to walk you through. Okay, the first page is going to have the 4 theorems that we've already talked about. So if you have this, I suppose you don't have to write this, but these 2 pages will be a really good one for you to be able to go back to and reference from, and that's why I am asking you to do that. And I'm going to show you a closer up of this. Okay, so the first 2 of the linear angles theorem, vertical angles theorem, please pause the video and copy this down if you have not done so already. And then next 2 are triangle angle sum theorem, and then exterior angle of triangle theorem. Please copy this down if you have not done so already. And then lastly, you have 5 boxes that should look like this. Corresponding angle theorem, that's the first one, and I do need you to draw these 2 parallel lines with transversal, and I need you to label the angles 1, 2, 3, 4, 5, 6, 7, 8, like so. And then next page will be alternate interior angles theorem, alternate exterior angle theorem, and same side interior angle theorem, and same side exterior angle theorem. Okay, we're going to fill this out today. So that is the reason you're going to do this, and we're going to get started filling it out today, but we'll continue next lesson as well. Okay, so at this point, knowing all those four theorems, so that's the linear angle theorem, the vertical angle theorem, triangle sum theorem, and the exterior angle sum theorem, you should be able to work on figuring out the different angles. So I want you to pause this video and draw this diagram in your notebook, and I need you also write down these given measurements. Okay, please pause the video. I also want you to note that EF is not a continuous line with FH. It's not a straight line going from E to H. So do not draw it like that. So if anything, you want to draw it indifferently so it does not look like a straight line. Okay, so if I was to continue this straight line, it would look like this, and I will modify the slides. Okay, and then you are going to go into your well, students went into breakout groups and worked on this together for 10 minutes. So where different students made a Jamboard copy of this from the link, and then figure out the different measurements. Okay, so you're using those four theorems that we talked about to figure out the angles, and you should be talking to your teammates, because and as you verbalize things, it's going to really be helpful for you as well as helpful for other people. Don't just go on to the breakout rooms and then just do it independently. Just talk about it and you see how far you can go, and see if you can explain why you think the measurement should be this. Not just what the measurement is, why you think it is as well. Okay, so that was the group activity. Now let's get into the angle pairs in parallel lines. So what is a transversal? A line that intersects two or more other lines. So if you have two lines, that red line is the transversal because it intersects the other two lines. Okay, and that is also another transversal. So when you have a transversal that cuts at least two lines, you are going to get 8 different angles are formed. 1, 2, 3, 4, 5, 6, 7, 8. 8 different angles are formed. So they all have angle relationship called corresponding angles, alternate interior angles, and same side interior angles, and alternate exterior angles. And now you're thinking, how am I going to remember that? Okay, so we're going to break it up. All right, so when we say something is corresponding in English language, corresponding things are in the same relative position. So for example, when you're talking about this Prius and this bigger SUV, the front left tire of both cars are not the same size, but they're in the same position relative to the steering wheel. So if you're just talking about these two wheels, they are in the relatively same position in relation to the steering wheel. It's just to the left of the steering wheel. It's to the left of the steering wheel, right? Okay, so when something is corresponding, they're in the relatively same position. So corresponding angles, that's what we're going to be starting off with. Corresponding angles are two angles at the same position of an intersection for two different intersections. There are two angles, so this is where you are writing down this description in the pages that you've left. Okay, so here is the diagram, and you should be able to see if you can make shading the area that corresponds to that the word corresponding angle. So can you do that as well? And so this blue angle and this yellow angle are corresponding because they are in the relatively same position. Okay, so corresponding means same relative position, same relative. So this in this intersection. This angle is on the